Good morning students, I hope you all are well today. So today we are discussing the chapter motion. We'll discuss about the graphical representation of motion in this class, how we can solve the graph questions in this motion chapter, how we can depict distance time graph. All these topics we will discuss in the today's class. Okay, so let's start. So first, how we can describe the motion? Motion is the change in position of a body with time. Motion can be described in terms of distance moved or the displacement. So how we can describe a motion? Motion is basically a change of position of a body with respect to time. If a body is changing its position with respect to time, then we can say that it is in motion. So for studying the motion, we have to study what is distance and what is displacement. So distance is the actual length of a path traveled by a body. Whenever an actual path is traveled by a particular object, then we can term it as a distance. But displacement is the final and initial position of that body. How we can describe the distance and displacement? You can see a straight line motion here. Okay, like suppose first let me tell you what is distance. Suppose a person start from this point O and he reaches point A and again he goes to point B. Okay, so total journey what he has done, he has started from point O, he go back to point A, then again he go back to point B. Now what is the difference between distance and displacement? In this case the distance will be OA plus AB. OA plus AB. Why? Because distance is defined as the actual path. So actual path of the object is covered is OA plus AB, that is 60 plus 35. That is 95 unit that object has covered. Okay. Now, sorry, to B it is 35, 25, 85. So total distance is 85. But if we talk about displacement, displacement is the position of initial and final position. Now initial and final is OB only and OB is 35, so displacement will be 35. Displacement here will be 35. Okay, that is the main difference between a distance and a displacement. Okay, next we have a uniform and non-uniform motion. What is uniform and what is non-uniform motion? A uniform motion, if a body travels equal distance in equal interval of time, it is said to be in uniform motion. Suppose a body is traveling with a uniform speed. Suppose a body is traveling with a uniform distance in uniform time. Okay, that means equal distance in equal amount of time. Then we can say that it is in uniform motion. Suppose a body is traveling. Suppose, let me give you an example. Suppose a particular body is traveling at, in 1 second it goes 5 meter, in other second it will go 5 meter, in the other second it will go 5 meter. So we can say that it is covering equal distance in equal interval of time. So yes, that body is in uniform motion. But non-uniform motion, if a body travel unequal distance in equal interval of time, suppose at first instance the body is covering 4 meter in first second, second the body is covering 8 meter, third body is covering 3 meter. So this is basically non-uniform motion. Okay, so I think you all have understood what is difference between uniform and non-uniform motion. Now what is the speed? The speed of a body is distance traveled in a particular time. Speed we can describe as a distance upon time. What distance has covered in particular time is speed. If a body is traveling distance s in time t, then speed v is v equals to s upon time. S equals to distance and t is time, v is speed, so speed equals to distance upon time. Okay, SI unit of speed is meter per second, or we can write ms minus 1. Both are correct. Okay, Now what is average speed? Average speed is the ratio of total distance traveled to the total time. What is the difference between speed and average speed? Speed we will just determine by distance upon time, but average speed will determine by total distance upon total time. Okay, that is the basically average speed. Now speed with direction. The rate of motion of a body is more meaningful if we specify its direction of motion along with the speed. The quantity which specifies both the direction, motion and speed is called velocity. Right now we have studied what is speed, but if we include another quantity with the speed, that is when we include speed with direction, then we cannot say that it as a speed, then we term it as a velocity. Okay, then we term it as a velocity, and then velocity is basically displacement upon time. Displacement per unit time is velocity. Okay, since velocity is magnitude, it is a vector quantity. Okay, and the SI unit of velocity is also same, meter per second. Velocity SI unit is also same, that is meter per second. Now average velocity is also same, total displacement upon total time, or initial velocity plus final velocity divided by 2. Okay, both we can apply here. Rate of change of velocity, if the velocity is changing per unit time, if a velocity is changing with respect to time, then we can term it as a acceleration. Okay, during a uniform motion of a body in a straight line, velocity remains constant with time. In this case, the change in velocity at any time interval is 0, no change in velocity. During non-uniform motion, the velocity changes with time. In this case, the change in velocity at any time interval is not 0. It may be positive or it may be negative. So in a uniform motion, the velocity always remains constant. So we can say that there is no change in velocity. So in uniform motion, we can say that acceleration is always 0. Okay. But if we talk about a non-uniform motion, in non-uniform motion, acceleration could be positive also, acceleration could be negative also. We will discuss about later on what is positive acceleration and what is negative acceleration. But right now just remember that during non-uniform motion, velocity changes with time. In this case, the acceleration could be positive and negative also. And the quantity which specifies change in velocity is called acceleration, and the SI unit of acceleration is meter per second square. SI unit of acceleration is meter per second square. This is the SI unit of acceleration. Acceleration is the change of velocity in per unit time. So we can write formula as acceleration is change in velocity upon time taken. Change in velocity is of course final velocity minus initial velocity upon time. So we got acceleration formula as A equals to V minus U upon T. Suppose you have given a final velocity and an initial velocity and the time is given, so you can easily identify the acceleration. Okay, so this is basically acceleration. Now uniform and non-uniform acceleration. Uniform acceleration, if the change in velocity is equal in equal interval of time, it is uniform acceleration. If a velocity is changing with equal amount of time, okay, if a velocity is changing in equal interval of time, then we can say it as a uniform acceleration. Okay, and if the velocity is changing with unequal interval of time, then we can say that it as a non-uniform acceleration. Okay, now graphical representation of motion, this is very important. So right now we have discussed about motion, then we have discussed about speed, distance, displacement. We have discussed that when we given another quantity with the speed when we express speed with the direction, we term it as a velocity. Then we have discussed about the acceleration, that rate of change of velocity is called acceleration. Then we have studied about uniform and non-uniform acceleration. Okay, now we will study about the graphical representation of motion, how we can represent motion in a graph. On a graph, how we can represent. So here we have given a graph. The change in position of a body with time can be represented on the distance time graph. This is a distance time graph, students. This is a distance time graph. You can see on the y-axis we have distance, and on x-axis we have time. Okay, so it is a uniform motion graph, and in a uniform motion graph, uniform speed graph, we are always getting a straight line. Okay, we are always getting a straight line because it's a uniform speed. The distance time graph for uniform speed is a straight line. This is because in uniform speed a body travel equal distance in equal interval of time. So yes, the body is covering equal distance in equal interval of time. You can see here in the 5 second it has covered 10 meter distance, and 10 second it has given 20 meter, so on it is covering. So we get a straight line. We can determine the speed of the body from distance time graph. Now how can we determine the speed of any object with this distance time graph? By using this distance time graph, how we can determine the speed? For the speed of the body between the points A and B, distance is s2 minus s1 and time is t2 minus t1. So I have to depict the speed from A to B. From this point A to this point B, I have to find out what is the speed. So with the help of this graph, I will depict the speed. So what we will do, we will make a parallel line to this point A and point B. We have made a parallel line to x-axis and y-axis. Okay. Now our distance is given. Distance is this. So our distance is given s2 minus s1 because this is our distance. What basically A to B has covered, this is our distance. So distance is s2 minus s1. Distance is s2 minus s1. And what is time? Time is t2 minus t1. Because A to B, time will be this t2 minus t1. Difference in time, of course, we'll write here. So our time will be t2 minus t1 and distance is s2 minus s1. So we all know that speed equals to distance upon time. Right now we have studied that speed equals to distance upon time. Distance is s2 minus s1, time is t2 minus t1. So s2 is 20, s1 is 10, t2 is 10, t1 is 5, 10 upon 5, 2 meter per second is the speed of that object between A to B. From distance A to B, the speed of that object is 2 meter per second. I hope by seeing the graph you can easily depict how you can identify, how you can calculate the speed of any object using the distance time graph. Okay, in this distance time graph you can easily depict the speed. Okay, let's move to our another graph. Now the previous graph which we have seen is of the uniform speed graph. For the uniform speed we always getting a straight line, but for a non-uniform motion, because previous graph is of uniform motion, but for a non-uniform motion we are not getting a straight line. We are getting this type of graph always. The distance time graph for non-uniform motion is non-linear. Non-linear means that the graph is not a straight line. This is because in non-uniform speed a body travels unequal distance in equal interval of time. Of course, in non-uniform motion a body is always traveling unequal distance in equal interval of time. So if you try to draw that graph also, you are always getting a non-linear line, non-linear graph. Okay, you are not getting a straight line. Okay, this is for non-uniform. And our previous graph is of uniform motion. Okay, I think distance time graph is understood by you all. Now we have velocity time graph. So in a distance time graph, we can easily calculate the speed by just determining the simple formula, speed equals to distance upon time. But in a velocity time graph, we have to determine the area under the velocity time graph. Okay, for determining the displacement, whatever distance, we have to determine the area. How we can do this? Let's see. Now velocity time graph. The change in velocity of a body with time can be represented on the velocity time graph. In this graph, velocity is taken on the y-axis and the time is taken on the x-axis. So on y-axis we have taken our velocity, on x-axis we have taken the time. So that's why it is called velocity time graph. So if a body moves with a uniform velocity, so first we have a uniform velocity. So if a body is moving with a uniform velocity, the graph will be a straight line parallel to x-axis. This is because the velocity does not change with time. Suppose the velocity is 20 km per hour and the velocity is not changing, so of course velocity will remain same at every instant of time. So we got a straight line for that velocity time graph. If a uniform velocity graph will make, we will getting a straight line parallel to x-axis. Okay. To determine the distance traveled by the body between point A and B with velocity 20 km per hour. Now I want to know what is the distance travel in these point A and point B. Okay. So how we are determining? To our velocity is 20 km per hour. We know that our speed equals to distance upon time, or we can write distance equals to speed into time. Okay, by this formula. Now our velocity or speed is given 20 km per hour. Okay, that is AC or BD. That is our velocity, and time is t2 minus t1. Of course time we will give by this t2 minus t1. Time is dc. Okay, time is this dc. Now what you will see in this ABCD, what image, what pattern it is? The pattern is a rectangle. Okay, and the area of rectangle is length multiply breadth. Length multiply breadth is the area of rectangle. So area of VT graph, area under VT graph always gives us distance and displacement. Okay, so length will get 20. Okay, AC we can write as length, and CD I can write as breadth. So AC multiplied by CD is our area of rectangle. So AC multiplied by CD, when we get, we'll get the displacement, particular displacement we'll get. Okay. So basically what we are getting, AC is 20 multiply T2 minus T1. This is the distance or displacement we are getting. Okay, understood? Now for difference. This is for uniform velocity. Now for a object whose velocity is increasing per unit time. Okay. If a body whose velocity is increasing with time, the graph is a straight line having an increasing slope. This is because the velocity increases by equal amounts with equal interval of time. The area under the velocity time graph is distance, magnitude of displacement of body. The distance traveled by a body between point A and E is the area ABCDE under the velocity time graph. So right now we have discussed that the area under VT graph always gives us distance and displacement. So this graph is basically of a increasing velocity. When a velocity is increasing with a perfect unit of time, equal interval of time, then we are getting the straight line like this. Okay, we are getting a straight line like this. Now if we want to take out distance between these point A and point E, of course we'll take out the area under the VT graph. So area we are getting is this AE. What is area we are getting? It is like this. That red color, this is our area. And how we can depict this area? This is area of A, B, C, D, E. This area will take out A, B, C, D, E area. Okay. Now A, B, C, D, E, what? Because this pattern we are getting. Now how I can break this pattern to get a simple formula? We can break this pattern into two categories, that is a triangle and a rectangle. First one is our triangle, second one is our rectangle. So by breaking the pattern into rectangle and triangle, by determining the area, we can easily calculate the distance. So our first is rectangle and triangle. So area of triangle is half into base into height, that is half multiply base AD into DE, AD into DE, plus area of rectangle, length multiply breadth, that is AB multiply BC. So this is the distance basically we are getting by a VT graph, by a velocity time graph. This is the distance we are getting, okay, and this is a increasing velocity graph. In the most of the questions you are getting this type of graph only, in most of the questions. And in the velocity time graph, if a question comes like this, we just determine the area under that. Suppose a question comes like this, and in the question it is asking you have to determine the distance between 2 points, and 2 points are given. Now in these 2 points, just determine the area under these 2 points. Whatever area you are getting under these 2 points, you get the answer, you get the distance or displacement. Understood or not? So this is our velocity time graph. Increasing velocity, so for increasing velocity we can easily write like this. Understood? Now, right now we have discussed if a velocity is increasing. Now we have other graphs like if a velocity is increasing as well as decreasing. So our first graph is for this. Our first graph is for uniform deaccelerated motion. Deaccelerated means when the velocity is decreasing per unit time. When the velocity is decreasing, then we can say that motion as deaccelerated motion. Okay, and this graph is for non-uniform acceleration, because the velocity is increasing then decreasing then increasing then decreasing. That's why we have a non-uniform acceleration for this graph. If a body whose velocity is decreasing with time, the graph is a straight line having a decreasing slope. We have seen in an increasing velocity graph, we got a graph like this with the increasing slope. This is for a increasing velocity. For increasing velocity, we got a graph like this, but for a decreasing velocity, we got a graph as a decreasing slope, like this. Okay, so this is basically the difference between these two graphs when we have a increasing and decreasing velocity. Understood? If a body whose velocity is decreasing with time, the graph is a straight line having a decreasing slope. This is because velocity decreases by equal amount with equal interval of time. If a body whose velocity is non-uniform, the graph shows different variations. This is because the velocity changes by unequal amount in equal interval of time. As you can see in this graph, velocity, first the velocity is increasing, then it is decreasing, then again it is increasing, and then it is decreasing. That's why it is a non-uniform acceleration graph. It is a kind of non-uniform acceleration graph. Okay, so I think all graphs you have understood what the graph means, how we can depict in a velocity time graph, because today we have learned two graphs. That is, first graph is distance time graph, distance time graph. In this distance time graph, we can easily find out the speed. Okay, second we have learned velocity time graph, VT graph. In the VT graph, in the velocity time graph, we have to find out the area under whatever the points we are determining to find out distance and displacement. To find out distance and displacement, we will find out this by VT graph. Now we have left with the three equations of motion. The three equations of motion are basically, we have done the formula also, that S equals to ut plus half at square, v square minus u square equals to 2as, okay, and a is equals to v minus u upon t. These three equations in the next class, in the next live class, we'll discuss about these three equations of motion, how we can depict these three equations of motion using our velocity time graph. Whatever the graph we have understood today, we'll do these three equations of motion, we'll do by the graph, and we'll discuss some questions, some numericals related to these graphs, okay. So I hope you have enjoyed today's class. I hope you all have learned what basically the graph means, what basically you can depict on the graph, okay. So that's all for today's class. Thank you everyone.